All right. Well, this last little bit is to kind of help us out with solving some equations. So we're going to talk about determinants and Cramer's rule. And I keep spelling Cramer's rule with a K, so I apologize for that. And then we have a little bit on using a TI 84 or 83 to help us solve these. This isn't necessarily going to, well, it can kind of help you a little bit with systems, no solutions or dependent systems, but it's still nice to be able to know how to do some of this by hand. Because who knows what you're going to be doing in the future. We're only going to do two equation systems as far as using determinants. Partly because at some point, it's just almost easier to use the Gaussian elimination to help with like three variable or more than it is to use determinants. Determinants, though, can be very, very, very quick and easy for two systems. So all a determinant is that if we have a matrix, we have a system of two variables. So let's say we have two equations that are going to be a1x plus b1y equals c1. And then we have a2x plus b2y equals c2. We can write an equation that's going to be a1, b1, c1, a2, b2, c2. So what we're talking about is there's different ways to write this, but if I have this system, I can simply look at the A1, B1, and A2, B2. So the determinant of the matrix A1, B1, A2, B2, what we do is we use straight lines to say determinant. It's denoted by the straight line, so we A1, B1, A2, B2, and it's defined by, we multiply this one, A1 and B2, and we multiply A2 and B1, and then we do the difference between those two products. We also say that the value of the second order determinant A1, B1, A2, B2 is just A1, B2 minus A2, B1. Like I said, part's pretty easy. Let's do an example of finding a determinant. We want to evaluate the determinant of the following matrix, which is going to be 10, 9, 6, and 5. So all we're going to do, if you want to, you can label it A1, B1, A2, B2. So what we're going to have is A1, B2 minus A2, B1. Or you can just go, we're multiplying these together. So we got the 10 times the 5, or the A1 times the B2. And then we multiply these together, which is the A2, which is the 6, and the B1, which is the 9. And we just do a difference. So this is going to be 50 minus 54. So we end up with a negative 4 as my determinant. Oops, and I have to go back and fix one little typo here because I just realized, sorry, my vision's a little off because of medication. We got a little thing right there. What I really should write, let me clear this and I'll rewrite it. Permanent, we're going to call D the determinant. We should have a straight line here. 10, 9, 6, 5. I don't know how I missed that with the matrix. Then we can go A1, B2 minus A2, B1. Or 10 times 5 minus 6 times 9. I'm going to get the answer wrong. It was just our notation was a little off. I'm going to use D going forward when we're trying to solve systems of equations to help us talk about determinants. And we're going to subscript this D a little bit too. So we'll subscript with an X and a Y. We'll see that. But we're going to do one more example of this before we try doing a system of equations. So try on your own the determinant. So don't do what I did. Remember that for your determinant, straight line, 4, 3, minus 5, minus 8. You can't write equals A1, B2, A2, A2, B1 here because this isn't the determinant. This is just the matrix. So we're going to make sure we write the determinant with the straight line. Okay, hopefully you had enough time to try this on your own. So like I said, kind of like cross multiplying, we take these two together. So this is my A1 and this is my B2. So we get the 4 times -8. And then we multiply these two together because this is A2, B1. Or we just say it's going to be 3 minus 5. It doesn't matter what order these in. I could have done -8 times 4, and I could have done -5 times 3. Be careful of your negatives when you're doing these products. So we're going to get -32 minus -15. So it's going to be -32 plus 15 equals -17. And that's the determinant of that matrix. So why do we bother with a determinant? Well, that's what we're going to be starting seeing here next. Cramer's rule says that if I have a system of equations that are a1x b1 plus b1y equals c1, a2x plus b2y equals c2, then x is going to be c1 b1 c2 b2 over a1 b1 a2 b2, and that y is going to be a1 c1 a2 c2 over b1 b1 b2 b2. So it's going to be the determinant of these matrices. So these are going to be different determinants. And later what I'm going to do is I'm going to call this one D2. I'm going to call this one dy. And this one here is just your good old-fashioned determinant that just uses these numbers in here. And one of the things we want to make sure is that the determinant of A1, B1, A2, B2 is going to not be 0, because if it is, then we can't solve our system of equations. So I broke this down again. So we're going to use D to denote discriminant. So given the system A1x plus B1y equals C1, A2x plus B2y equals C2, we're going to have 3 determinants that we need to find. We're going to have D, which is the determinant of everything that's in here. So I'll kind of explain this. So for doing these two, basically it's like we are ignoring these two numbers. So we get A1, B1, A2, B2, the determinant of that matrix there. Then what happens is when I want to do dx, this is going to help me figure out what x is. We're pretty much just ignoring all of x and we're focused on this. So this ends up turning into the determinant of your matrix C1, B1, C2, B2. So that's the hardest part, is just that little switch there where we put the C's first, because then we go back to normal here. Would make sense. So if I want dy, then we just ignore the x's and we just focus on this. Oops, sorry. Ignore the y's and we focus on what's left, the a's and the c's. So we had A1, C1, A2, C2. So we know how to build those matrices. So if we want to find the solution to this system of equations, x is just going to be your determinant of your dx over your d, and y is going to be your dy over your d. I know this sounds crazy, but let's do an example here. So like I said, we need 3 different matrices. So I'm going to make extra space here. Not necessarily matrices, but 3 different determinants. So we want this determinant, which is A1, B1, A2, B2. Then we want dx. which is C1, B1. Oh, C1, B1. I said 1, but I wrote 2. C2, B2. Then we want the determinant for this y part, which is going to be our a's. So it's going to be A1, A2, and then C1, C2. So if we go back up here, right? A1, B1, C1, A2, B2, C2. So if I just do this matrix right here, it is going to be, we're looking for the determinant of the matrix, would have been 5, 4, 3, -6. So remember, the straight lines are just telling me I'm doing a determinant. So like I said, it's the cross multiplying. So 5 times -6. And then this cross multiplying to 3 times 4. And we're doing a difference. This is -30 minus 12. This ends up being -42. So that's my D. And we're going to write it over here. D, the determinant of D is -42. Your dx. So you're going to do your C1. So 12, your B1, which is 4, your C2, which is 24, and your B2, which is -6. You're going to do the 12 times -6. Just kind of put my place here. Minus this cross multiplying the 24 times the 4. So I think this is -72 minus 6, 8, 96. That's going to be -168. Yep, that's what it should be. So dx is -168. Now your dy, A1 is 5, A2 is 3, C1 is 12, C2 is 24. So cross multiply 5 times 24 minus cross multiply 3 times 12. So this is going to be 0, 10, I think it's 111 minus 36. And you should get 84. A second, just want to make sure I didn't make a mistake there. Yeah, this should have been 120. As I said, something didn't look right there. 120 minus 36. And then you're going to end up with the 84. So dy is going to be 84. Okay, so let me highlight this. So this is an important part. We know what d, dx, and dy are. So let's figure out what x and y are. So as a reminder, if you want x is your dx, or your determinant, or your sorry, try this again, your dx determinant, your d determinant. So that would be the -168 over the -42, which should give you 4. Then your y is going to be your dy over your d. Your dy is 84. Your d is -42. So this is -2. So what we have here for my solution, I've got something coming up in my way here. So my solution is the ordered pair where x is 4 and y is -2. You could try that. So 5 times x, that's 20. 4 times 2, that's -8. 20 minus 8 would be 12. 3 times 4 would be 12. -6 times 2, that would be 12 again, because negative times a negative. So 12 plus 12, 24. Yes, that is the system, the solution to our system. Oh, there you go. Sorry, I thought it wasn't working. So take a moment here and use Cramer's rule on this system equation. So x2y minus 3, 3x minus 4y equals 4. So find your d, dx, dy determinants, and then figure out what your x and y are. Okay, so the basic setup here. Like I said, we know what our A1, B1, C1, A2, B2, C2 are. We just need to set up the matrices. So B is the A's and the B's. So we end up with this coefficient of 1. We end up with 1, 2, 3, minus 4. So we need a determinant of that. So that's going to be 1 minus 4 minus 2 times 3, which is going to be a -4 minus 6, -10. So your dx, that's going to be your c's, then your b's. So 3, 4, 2, minus 4. Do the determinant. So we got 3 times -4 minus 4 times 2. That's -12 minus 8. This ends up being -20. And then we have the A's and the C's. So 1 and 3, and then 3 and 4. So we get 1 times 4 minus 3 times 3. 4 minus 9 equals -5. If you did this one, you end up with a fraction. You did everything right. So remember, x is just dx over d. -20 over -10, which is going to give me 2. And then your y is going to be your dy over your d, or -5 over -10, which is 1/2. So my solution is the ordered pair 2 and 1/2. All right, so try this one more time. So this one, notice that it's not written as x, y, and then the constant. So you have to rewrite the equations, then make your matrix, then work on solving it. So hopefully you had a moment. And then I really said we were making a matrix. We're not making a matrix. Um, You should end up, if you solve these, so your x and y's are to one side, you should have 4x plus y equals 2, and then 2x minus 3y equals 8. If we wanted to, we can write above it. Sorry, something's not working right here. There we go. My matrix would be 4, 1, 2, and 2, -3, 8. So my A's, my B's, my C's. D will be the A's and B's. So 4, 1, 2, -3. So we're going to get 4 times -3 minus times 1. So -12 minus 2, we get -14. dx, that's my C's and my B's. So that is going to be 2, 1, 8, -3. So 2 times -3 minus 8 times 1, that is -6 minus 8. So negative 14 again. And then dy is going to be your B and C, sorry, your A and your C. So that would be the 4, the 2, the 2, and the 8. 4 times 8 minus 2 times 2 is going to be 32 minus 4, which is going to be 28. So x is dx over d, which will be negative 14 divided by negative 14, so that will be 1. Y will be dy over d. Looks a lot like something else we're writing here. Where was I? Oh, that's right. So 28. I don't know why I could say that over 14, since it comes out of negative 2. So my solutions going to be the ordered pair 1, negative 2. Once again, you can always go back and see if x is negative 2, then we have negative 4 times, or sorry, if x is 1, we have negative 4 times 1, which is negative 4 plus 2, negative 2. If we put a 1 there, so then we have 3 plus 8. Oops, wrong one. This is the one. If we have 2 plus 1, that's 2. If we have 3 times negative 2, that's negative 6 plus 8. That's going to leave me with a 2. So it works. That's my solution set. All right.